Welcome to this tutorial on composites design. During this video, you will acquire knowledge about the solid slicing approach design method on CATIA 3DEXPERIENCE. Before starting the manipulations, let's talk about the solid slicing approach design method. The solid slicing approach design method is used for the cases where the two surfaces outer mold line and inner mold line are imposed. This method is similar to the grid approach design, except the plies are generated based on the volume of a defined solid instead of the ply stack-up definition. This approach is recommended and preferred when the final shape of a part is critical. Using this method, the user can slice the associated solid that is created using the zones for creating plies. This method consists of two sub-steps: slice the associated solid created from the zones to create the slicing curves, and create the plies using the slicing curves. For this tutorial, we will use this geometry, an engine blade. Download the file attached to this tutorial, and save it on your computer, in a directory of your choice. By the end of this tutorial, you will be able to log into 3DEXPERIENCE and prepare the environment, create a zone group, define a zone, define a slicing group, and finally, generate plies from the slicing group. Let's get started. Let's start the manipulations. First of all, you have to log into the 3DEXPERIENCE platform. Open the 3DEXPERIENCE login window, and use your ID and your password to log in. Once you have logged in, click on the compass and search for the Composites design application. Launch it. Once the application is opened, click on the plus button at the top right and click on Import. Import the file named engine_blade.3dxml that you put in the directory of your choice, and as soon as the import is complete, press Ctrl+O to open the part, or right-click on the 3D part, and click on Open. Ensure that the part is open in the Composites design application. First of all, let's create a zone group. A zone group defines the surface, draping direction, and rosette. Zones groups can be used to structure the part early in the design phase, before defining individual plies. This gives the designer flexibility. For instance, for a core stiffened panel, the designer can use two unique zone groups designated to plies under and above the core. To create a zones group, click on the zones group icon within the action bar. Select the OML surface. Once the surface has been selected, the draping direction is displayed by a red arrow in the geometry area. The draping direction should be towards the inner side. Click the reverse direction button to invert the draping direction. Next, select Rosette.1 and select the Display Label checkbox. Notice that the rosette is displayed in the geometry area. Click OK to create the zones group. Observe the zone group is now contained in the model specification tree. Now, let's define a zone. It should be noted that a zone must be located in a zone group. A zone is a geometrical area defined by a geometry, a constant laminate, and a rosette. Zone geometry consists of contours that fully lie on the surface of the associated zone group. The laminate describes the number of layers per material, direction association for a zone. In the Zones Design section of the action bar, click on the zone icon. Select contour curves for the zone as shown. You can directly select the wireframe elements in the geometry area or select the curves from the tree. Then, switch to the Laminates tab, and select the TL.1 laminate from the drop-down list. Click OK. Observe that the zone is created under the Zones Group node in the specification tree. Let's define a slicing group. The slicing group command from the Zones Design section of the action bar allows you to generate the base curves of the plies contours by slicing the solid. You can generate several slicing curves group features in a composite part. Many designers slice portions of the solid and then reconcile the curves using the merge contour options. First, in the Zones Design section of the action bar, click on the slicing group icon. Select the solid and select the zones group previously created in the zones group field. It is recommended to select the zone group corresponding to the solid. There are two slicing methods. With the thickness law method, you can use this method when the zones selected in the zones group comply with the staggering rule. This method supports multi-material zone scenarios. The material and the direction information are applied to the plies. And, with the constant thickness method, you can use this method if the zones do not comply with the staggering rule. The contours of the plies are generated using this constant thickness. If you select this method, specify a value for the slicing thickness. In our case, select the slicing method as thickness law. Then, select the computation mode as discrete and specify the parameters as shown. In the discrete mode, the upper surface of the solid is discretized using the sag and the step parameters. The slicing curves are computed from the discretized view and smoothed using the curve degree value. The default values of the parameters are accurate enough for most requirements. If required, you can edit the values. For the curve degree value, you can specify 1 for linear result for tape layering, and 5 for fillets in the reference surface. In the exact mode, offsets of the support surface of the zone group are computed using the selected slicing method. The slicing curves are computed by projecting the intersections of the offsets with the solid onto the support surface. The sag, the step, and the curve degree parameters are disabled here. Click on the Reduce Micro Edges checkbox. Slicing is done in patches. If you select the Reduce Micro Edges checkbox, the underlying patches are grouped by tangent continuity. This is useful when a surface has many underlying patches as it reduces the number of edges on the contour and removes microedges. But when the composite part is stretched, the curves do not need to follow the composite design. You can select the Force Simplified Computation checkbox to simplify the result. Finally, click OK. The curves are created in the tree under the Slicing Curves group of Zones Group.1 node. They are grouped by geometrical level, each of which corresponds to the altitude of contours. Finally, let's generate plies from the slicing group. In the Zones Design section of the action bar, click on the Plies from Slicing icon. Select the slicing curve group previously created from the specification tree as the slicing feature. Either specify the target plies group if you want to insert the new plies in an existing plies group, or select the Create New Plies Group checkbox if you want to insert the plies in a new plies group. In our case, select the Create New Plies Group checkbox. Finally, click OK. Observe that a plies group containing plies is created in the stacking. This is the end of the tutorial. In this video, you learned how to log into 3DEXPERIENCE and prepare the environment, create a zone group, define a zone, define a slicing group, And finally, generate plies from the slicing group. Don't hesitate to watch this tutorial again, and reproduce all the steps by pausing the video.